Good morning, guys. We'll solve this numerical on simply supported beam with the overhang. And you see at the left side there is a overhang. And it is the way the numericals will be given in the examination. So you need to convert this into first what? A free body diagram. So convert this into free body diagram by actually replacing this with a force. So you replace this with the force here. So these are two forces which are replaced. These are basically supports. Supports. What is the support doing? It's applying a force from bottom. So replacing this. So once you replace this, then what is the other thing that you have to do? Moment. Moment at A, moment at B, C, D, and E. So you got the moments at this, and then once you have done this, without forgetting, you need to do something. What is that? Now, what is that you need to do after this? So basically, reserve the place for this because usually people forget and then they start doing the numericals and then they end up drawing this diagram once more. It is better always to reserve this place below. So these can be light lines. So these lines can be light and only those SFD BMD can be dark. Okay. These are only reference lines. Okay. So once you have done this, now these are basically supports, and all these values are known. These two are not known. So earlier, what we used to do, we used to take the left side sigma ma is equal to 0. Suppose if you start solving like this, then you will end up with the equation where you have got RA and RB both. And there will be two unknowns in the equation which you can't solve. So therefore, I think many people will do this mistake. When you got a hinge which is not on the sides, on the left hand side, people may take sigma ma and end up having two unknowns. You can't solve that. So what you have to do, you should take not with respect to A, you should now take it with respect to B, so that one unknown is eliminated. Okay. So now let us take all the moments which are trying to make this clockwise as positive, anti-clockwise as negative. So about B, which are actually trying to make positive here. C is trying to go positive. This is going positive. This is going negative. What about this? Negative. It is negative. So you know what are positive and what are negative. So start from this. So RA minus RA into how much? So much distance from B? 1 meter. 1 meter. And then plus 20 kilonewton into 2 meters. Sorry, 1 meter. 1 meter. And again plus 30 into 2 meters. Is this visible? Yes. And then minus RE into 3 meters is equal to 0. Minus RE into 3 meters is equal to 0. So now, sorry, RA I have written wrong, sorry. Here RA value I know, sorry. So I should write it as 20 kilonewton. I should write it as 20 kilonewton. So here only when there is only unknown. So please find out the unknown.
20 kilonewton.
RE is equal to? RE found it as 20 kilonewtons here. And then once you have found out this RE, then sum of the forces, sigma F is equal to 0. So that means going downwards is equal to going upwards. So going upwards is equal to going downwards. So going upwards are the two forces which are actually RB plus RE, which are going downwards. How many are going downwards? 20 kilonewton plus 20 kilonewton plus 30 kilonewton. So all these are going downwards. Substitute this value of 20. So RB will be equal to how much? 50 kilonewtons. So RB is 50 kilonewtons. So first you have set a platform where you have found out the reaction forces. So reaction forces were, so RB at RB, the value of reaction from RB is equal to 50 kilonewton. Obviously, you got a overhang here, so it is taking more load here, and this side it is taking less load. This is actually 20 kilonewtons. Okay, and then once you have done this, then the remaining steps follow. So what I'll do, so hoping this is done, so there is this side of the area here. Okay, and then I need to draw SFD here. SFD, reserve this place for SFD, and draw SFD here. This is the 0 line, 0 kilonewton. Of course, the way we started is, if you imagine that this beam continues here like this. Okay, here you are taking a section here, and what is the convention basically? The convention says if it is the beam and if it is the section that you are considering, if it is the section that you are considering, any forces downwards onto the right side is positive, any forces upward on the left hand side is positive both. So okay, now as I see here, any forces on the right side? No, 0, 0, 0, 0, 0, 0. Until now it is 0. And now once you cross this point, there is one force going upwards. What is the value? 20 kilonewton. Is it plus or minus? Minus. It goes from 0 to minus 20. It goes from 0 to minus 20. And as you actually move this across, it will remain 20. It will remain 20. Okay. And then you'll see that as you again cross this point, so this is 30 going downwards is plus, so this is minus 20 plus 30, it becomes plus 10. It becomes plus 10. This is 20 kilonewton. Okay, and then as you go further, that there are no change in forces, it will continue to be like that. Again, one more force gets added. From 10 it becomes how much? It becomes 30. Guys, these are just addition and subtraction. If you can't do this, then you have a serious problem with your brain. Okay. So then you're here. So then again there is one more force, 50, going upwards. It is 30 minus 50. How much it is? It is minus 20. It comes to minus 20 again. Okay. Of course, you don't have to see it until this point. You can start seeing it on the left hand side. So instead of seeing it on the right hand side, you can start seeing on the left hand side. Left hand side, anything going upwards is positive. So here, no forces. Here, no forces. And again, here, 20 kilonewton downwards. So it is minus. It goes to minus here. It goes to minus here. So 0 to 0 kilonewton, and it goes to minus here. And then, okay, as you go further here, from here to here, you will see it remains 20 here. It remains 20 here. As you go further here, minus 20 plus 50, it goes to 30. Now, whether you want to see like this, whether you want to see it like this, it's left to you. Okay. So once you have done this, now shade this area, that gives a clear indication that somewhere in between B and C you got the highest shear stress. So that is a danger zone. So maybe you need to take care of the beam there. For suppose if you have issues in failing by shear. Guys, meanwhile you also draw, because I am not giving a separate time. So shade this area. Okay, so once you have done this, Then you can now draw bending moment diagram. Okay, bending moment diagram. Let me draw zero line first. Now what do you think? Will this bending moment actually come above or below? Above.
Sagging.
See here, you will see that from here to here it is sagging. Guys, by common sense. By common sense, suppose if a beam is like this, with the supports. If you apply a load here, it sags here. It sags like this. Suppose if the beam was continued like this, and suppose if you have got one more load here, then it starts to bend like this. Guys, you see here, suppose wherever the curvature is like this, it is sagging, it is positive. Wherever the curvature starts becoming like this, ulta. Okay, here it is like this. From here it starts becoming ulta, like this. So here you see somewhere here, it is actually changing from positive to negative. This you will understand that we call this point as point of contraflexure. Guys, current listening?
Yes, sir.
This point is called as
Point of
contraflexure. So what is actually flexure? Flexure means bend. What is actually contra? Contra means ulta, opposite. So contraflexure means bend opposite. So that means it starts bending from sagging to hogging. This point is point of contraflexure. You will find somewhere here. Expected. Now this beam would have bent like this, but there's a force here. So you're expecting this beam to go like this, bend like this. Somewhere here, the sagging part will become hogging here. Somewhere. Now you should expect here. Okay. You can find where is this. Okay, now we'll start to draw bending moment diagram. So, is this visible? If I go here?
No, sir. Not visible.
Not visible. So, we'll have to. Okay. Now, what is the convention for bending moment? So, if it is the beam,
upwards positive both sides.
upwards positive on both sides, which will actually create sagging. Okay. So here, if I continue this beam, there are no forces here, no distance. So bending moment is zero. Bending moment is force into distance. Force is kilonewton, distance is meter. It is 0 kilonewton meter. And then suddenly here, there's a force, but is there any distance?
No, sir.
No distance, so it is still zero. But as I go with the distance, it starts increasing with the distance. It starts increasing, and it becomes maximum at this point. Okay, what is the value now? 20 kilonewton into 1 meter. So much is this?
20.
It is actually 20, and it is upwards on the right hand side. It is 20, 0 to 20 here. It goes from 0 to 20 kilonewton meter. Okay. Now as you go further here, you get these two forces added, 30 and 20. And when you come to this point, you will see two forces.
20 into 2.
So let me write here. So of course, bending moment at D was easy. So that is 20 kilonewton into 1 meter, which was actually 20 kilonewton meter, which was positive. Bending moment at C is equal to
20.
so 20 kilonewton plus 20 into 2 meters minus
30 into 1.
minus 30 into 1 meter. So what is the answer? So that is plus 10 kilonewton meter. So that means it goes again from plus 20 to plus 10 somewhere here. Okay, this is plus 10. Suppose if this is 20, this is 10. So you can approximate. You don't have to literally measure this distance as 2 centimeter, 1 centimeter. Like approximate this. And then again, if you feel that you are again going this way, you will have to have a lot of forces to calculate. See this way. From here you have already got 10. So now as you go here, as you go here, you will see this point at bending moment at B. Bending moment at B is how much? So there is a force here which is going downwards. Is it positive or negative?
Negative.
That's negative. So bending moment at the B, that is minus 20 kilonewton meter into 1 meter. Okay. So that will be equal to how much?
Minus 20.
Minus 20 kilonewton meter. So you will see that at B it goes from plus to minus. So first time you are seeing that the bending moment diagram from positive it's going to negative, because earlier you had only two supports and all the loads were in between. Now you have got loads across the support, so somewhere it is trying to hog. Hog means like this, sag means like this. Okay, so it's going to hog here in this zone. From sagging to hogging, you'll find the contraflexure. You'll now find it. So it goes from plus 10 to minus 20 here. So minus 20, this is 10. So 20 can be this much. Is it seen? Is it visible? Okay. Okay, this is it. And what about this bending moment at A? So what about the bending moment at A?
0.
0, because you're seeing on the left hand side there are no forces, nothing. So it is 0. 0 kilonewton meter, and you join this. This problem would have been very difficult, slightly difficult if there was UDL. I think with point loads it is just multiplication, state multiplication, no issues. So now you see this, now you see these diagrams here. So please share this so that it looks good, and also you see this diagrams, because you write in rule sheets these lines may get confused. The examiner may not clearly say this. Guys, in the examination don't write in pencil, because the scanned answer books may not scan the pencil marks clearly. You feel you have done SFD BMD for the examiner, there's nothing visible. Don't get into that trouble. Please mark this SFD BMD in pen. Finally, after doing it, darken the outlines with pen. Guys, you learned a new word this class. No, what is that? Point of contraflexure. So what is point of contraflexure? Where the bending moment goes from positive to negative. Where it is going? It's going here. It's going here. So you should locate this. It is also important because the engineers need to worry where to strengthen. Where to strengthen, whether you need to strengthen it from the bottom side or the top side. So where it has to actually change. So basically you know that anything which is bending like this will have compression at the top, then you will have actually tension at the bottom. And suppose if you got one, again in this part of the beam it goes like this. Again you will see the tension at the top and the compression at the bottom. So wherever there is tension, the material can crack due to the tensile failure. Usually concretes can take a lot of compressive loads. Of course, we are speaking about civil engineering, but even in the mechanical structures, sometimes the compression members can actually get bent. So you can suitably think what you can do at this point, where it is changing from compression to tension, what you have to do. So as an engineer, you will know it. But right now at this point of time, you just need to understand that it is a location where this beam is changing from what? Sagging to hogging. Okay, you expected somewhere here, no? So expected somewhere here. So expected that the beam will bend like this. From hogging, it will change to sagging. You expected somewhere here. You're seeing it here. Okay, so how do you locate this point? Look at what distance is this point. How do you locate it? How do you locate this? So you can actually convert this into a triangle, something like this. Now what is the total height of the triangle? The total height of the triangle is 10 plus
30.
So The total length of the triangle is 30. And what is the length of the triangle at the bottom? 1 meter. So it is actually 20 by 1 meters. Sorry, the 30 by, so this is 30. 30 by 1 meters. And this is how much?
1 minus x.
This is actually 20. So 20 divided by x meters. So in that proportion. So you can say 30 by 1 meter divided, I mean, that's in the same proportion of 20 divided by x meters. X meters you can find. So what is x meter?
0.66.
X is equal to 0.66 meters. So x is equal to 0.66 meters. So if you mention this, the point of contraflexure, so people can write point of contraflexure POC, something like this you can write. The point of contraflexure easier. So examiner wants to know this, where is it? So it is better instead of showing the calculation here, you also mark this location here. So examiner is happy that you have actually shown it. Okay?